Okay, this section is about graphing piecewise functions, and basically it's just a review of graphing. The only difference is that a piecewise function restricts the domain of your graphs. So basically it takes a bunch of graphs and creates one new graph by using pieces of the original. So let's just kind of practice a little bit of the domain first. So we're going to just go through the domain of these first 5 questions. So because these are 3 individual ordered pairs, remember, you have to do the domain as 3 individual x values. So your domain is 2, 3, and 4. Use your braces to denote that that's those separate points right there. We're not going to do brackets because remember, if I said 2 to 4 like this, then that would mean that I'm talking about all the numbers between 2 and 4, and I'm not. I'm just talking about the specific numbers 2, 3, and 4. I don't want 2.5. I don't want 3.7. I only want those individual values. Okay, over here, number 2, that is a parabola. So the domain of all parabolas is all reals. And number 3, this is a square root. Remember this one right here, if we do a quick sketch, it's moving left 3. And it's the sideways parabola. It opens to the right. So that means my domain would be x is greater than or equal to -3, or you could do it in interval notation and do -3 to positive infinity. Okay, down here I've got some graphs. So this one down here on the bottom left or top left now is not a line, it's a line segment. It falls between these 2 boundary lines here. So that means the domain of this one is between 1 and 7. Or I could say x is less than or equal to 7, greater than or equal to 1. So that's the domain of that function. Okay, over here on the right, it looks like I've got a bunch of line segments. So I'm just going to kind of put in the domain boundaries here of those pieces, and we'll see what happens. Okay, so this segment here on the left is just a horizontal line, and it looks like the domain is, that piece looks like it's going from -7, so the domain is going to be from -7 to -1. But it looks like to me that's a closed circle, so it's kind of hard to see because I've kind of got my dashes there. We've got an open circle and a closed circle, but down here, the one below, that's closed, and so that's going to kind of overlap with us. So right now, we still get to count -1 into our domain. So I'm going to erase that. Moving along to this next boundary line, you can notice right here is an open circle, but here is a closed circle, and they are lined up, so that kind of overlaps. So really, our domain is going to end up going from -7 all the way to +8. Even though the graphs have breaks in them and they're not continuous, the domain is continuous because everywhere I had an open circle, I had a closed circle that overlapped in that same x value. So my domain is continuous even though the graphs are not. So you could write it -7 to +8, or you could do that in inequality notation, like that. All right. So here we go. This is using function, or excuse me, piecewise notation. So what happens first is over here, you're just going to use one f of x. I've got 2 functions over here. I have 2 lines, but I don't write f of x equals each of those individually. I just write the f of x one time. And then this set right here, that's your domain. Okay, so this is my domain. So that's the parts of your piecewise function. You've got the function name over here on the left, so this is your function name. You've got the 2 functions in the middle, so here's your 2 functions right here. And then your domain restrictions over here. All right. First thing I'm going to do is I'm going to go ahead and put in my boundary line. I'm looking over here at the domain, remember, and I see that 2 is the only number, so I'm going to come over here and I'm going to just draw a dotted line at 2. This is not part of my answer. This is just a tool to help me graph the piecewise function. And now I'm going to do the first line. So the first line says that we're supposed to go up to 4, and then so I'm going to do this function right here with this domain. So I'm going to go up to 4, 1, 2, 3, 4, and then the slope is down 1 over 1. When I get to the domain, the boundary line, over here it says I only want where x is less than or equal to 2. So I am not going to keep moving to the right here. That doesn't make sense. I only want the stuff that's on the left-hand side of the boundary line. So I'm going to go the other direction. So I'll connect those points. The only thing you have to do is look to make sure that on your boundary line that you have the point either opened or closed. Now, default, guys, is even if it doesn't look like it's a closed circle, it's always closed circle unless you specifically see an open circle drawn. So this right here is equal to, so that means this is a closed point over here. All right, on the boundary line. Okay, now I'm going to do the other one. Now I'm going to do the other equation down here on the bottom. I'm going to do 2x minus 2, that line. So I'm going to go down to 2. And then my slope is up 2 over 1. Up 2 over 1. Even though I had to start in the other boundary area, I'm not going to count those as my final answer. I'm going to keep counting this out, and then I'm only going to use the points I need to. Up 2 over 1, up 2 over 1, up 2 over 1. Okay, so I'm going to connect those. On the boundary line, it says it's supposed to be an open circle because it's just less than, right? Just less than right here. No, equal to. So open circle, but I already have a closed circle there. So if you have an open circle and a closed circle, it's still a closed circle in the same spot. Okay, now I've created my piecewise function. That is my piecewise function. The boundary line is not part of the answer. I could erase that. The only answer is, oh, whoops, went too far, is that V shape. So that's my piecewise function. It's two parts of two lines to create that V shape. Okay, now I can answer any questions I want. Over here, I'm going to put, I'm going to add a couple more. I'm going to do f of 20 and f of negative 13. Okay, so I'm going to do f of 3. If I were to come over here to my graph and I counted over to 3 right here, I could go up 1, 2, 3, 4 right there. That would be my answer. So f of 3 is 4. I could come and do negative 2, same way. So I'm going to count 1, 2, and then I'm going to go up 1, 2, 3, 4, 5, 6 till I hit my graph. That would be 6. And then f of 0, here's 0, 1, 2, 3, 4. I hit my graph, so my answer is 4. Okay, f of 20, unfortunately, is off my graph paper. I can't go over to my graph and see the answer. So I'm going to have to use the equations to do that. So if I want to do f of 20, I have to figure out what boundary would 20 be in. Well, 20 is definitely greater than 2. So I want to use this formula right here. So I'm going to say f of 20 is 2 times 20 minus 2. So that's 40 minus 2, which is 38. And then f of negative 13, well, once again, go look at your boundaries and figure out where negative 13 would be. Negative 13 is definitely within this boundary, so I'm going to use the top equation. So I'm going to say, be careful with your negative signs. It's a negative, parenthesis, negative 13 plus 4, and so that turns out to be 17, which makes sense. If I was over here at negative 13, to the left over here, negative 13, I'd be up positive 17. That kind of matches my graph. And then the same thing on the other one. If I were going right 20, would I end up being about 38 high? Probably, if we could get that all the way scaled out. Okay, let's do this one again. Okay, now this one has 3 functions that I'm using. I'm going to do a quick look over here on my boundaries to see what's going on. So I'm going to check the boundaries right here. It looks like I've got a 2, a 4, and a 9 for boundary lines. So I'm going to come over here and put my little dotted lines at 2, 4, and 9. And now I'm just going to graph those particular functions in those regions. So first one I will do is top one. So this one is only where x is less than or equal to 2. So to the left of this boundary line right here. So we have to go left of that boundary line. So it's a parabola, so I'm going to go up 7. And it's negative, so that means my parabola is facing down. So I'm going to go down 1 over 1, down 3 over 1, down 5 over 1. And I'm not going to go down 5 over 1 to the right, because then that will put me in another boundary area, which I don't need. So here's my parabola with the domain restriction given. On the boundary line, it's a closed circle because it is equal to right here. So that was equal to, so it's a closed circle. Okay, now I'm going to go and do the next one. The next one happens to be y equals 3. Okay, well, y equals 3 is a horizontal line at 3. So I'm just going to count up 3 and do a horizontal line. Okay, on my boundary lines on 2, I'm supposed to have an open circle right there because it's not equal to. Well, I already have a closed circle, so it's going to be closed. And then on 4, it's equal to. So I'm going to do a closed circle right there. Remember, it's always closed unless we draw it open. You don't even have to draw that exaggerated point if you don't want to. Okay, and then the last one is between the boundaries 4 and 9. So I'm going to do x minus 3, and that's a straight line. So I'm going to go down 3, 1, 2, 3. Now I'm going to have to go through a lot of boundary areas till I can get to where I want to be, but that's okay. I just won't use them in my final answer. So I'm going to go up 1 over 1, up 1 over 1. Okay, now I'm in my boundary area. Up 1 over 1. Going to connect those points. Check my boundary lines. Open circle here, definitely. Closed circle there. It's always closed unless we draw it open. Okay, so what's our graph look like? We'll get rid of all this extra points. We don't need any of those. Don't need my boundary lines. They're just tools to help me draw my piecewise. There's my piecewise function. All right, so I'm going to do these, and I'm going to add one more. I'm going to add f of 4. I'm going to do these all algebraically, and then we'll go over and check them graphically. So f of 3. So if I want to do f of 3, I'm going to use this formula right here. Except I don't know what to put in for the 3 if there's no variable here. Well, remember, this is a horizontal line, so it doesn't matter what your input is. Your output's always going to be 3. So there's my 3. Okay, so well, let's just come over and see if that really is true. 1, 2, 3, up, 1, 2, 3. Yep, match. Okay, next one. F of negative 1. Well, negative 1 is definitely less than 2, so I'm going to use this formula right here. So I'm going to go negative, parenthesis, negative 1 squared plus 7. So that's going to turn out to be a negative 1, raised to the second power is 1, times a negative, so this is 1. Then you have to times it by the negative 1, so that's negative 1 plus 7, so that answer is 6. Okay, let's just come over here and see if it really matches. We'll come over here to the right. We're going to go over negative 1, 1, 2, 3, 4, 5, 6, and it worked. Okay, next one is 7. F of 7. Well, 7 is definitely between 4 and 9, so I'm going to use this formula. So I'm going to 7 minus 3 is 4. So I'm going to come over here to 7. 1, 2, 3, 4, 5, 6, 7. Count it up. 1, 2, 3, 4. It matches. Perfect. Okay, and f of 4. You have to figure out what boundary line to put that one in. So f of 4, if I look here and here, because that's where I see the number 4, the middle one is the only one where the 4, it's equal to the 4. So that must mean my answer is 3. Well, let's come over here and see what's happening at 4. So when you come over here to 4, 1, 2, 3, 4, right here, notice this was open right here and it was closed right here. So yep, it was closed at the 3, so our answer was 3. Okay, here's another one. Looks like we only have one boundary line on this one at 2, so I'll just hurry and sketch that in. Top equation is a parabola with a vertex at 1, 4. So I'm going to come over here 1, up 4, 1, 2, 3, 4. It's positive, so this parabola opens up. So up 1 over 1, up 3 over 1. On the 2, it's a closed circle. So there's that part of the graph. And then this one is a square root with a starting point at 2, 3. So I'm going to go over 2, up 3, 1, 2, 3. It's an open circle right there because it's not equal to. So open circle. Then that's our sideways parabola. So I go up 1 over 1, up 1 to the right 3, up 1 to the right 5. And there's our shape. So there's our piecewise. F of 2, you would put the 2 in the top equation. You would go 2 minus 1 squared plus 4. That's where it fits in the boundary line. 1 plus 4 is 5. Well, let's just go see if that really is true. Come over here to 2, 1, 2, 3, 4, 5. So, yep, it matched up. So that worked. Okay, the next one, 6 is greater than 2, so that's going to go in the bottom equation. So 6 minus 2 plus 3. Well, 6 minus 2 is 4. Square root of 4 is 2, and 2 plus 3 is 5. Well, we could count that out. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yep, it matches. And the last one, -1 is less than 2, so that's going to go -1 minus 1 squared plus 4. So -2 raised to the second power is 4, and 4 plus 4 is 8. All right, let's just see it. -1. Here's -1. 1, 2, 3, 4, 5, 6, 7, 8. It matches. Okay, now we're going to go in the other direction. We're actually going to write the piecewise. So we need to figure out what our boundaries are first. So it looks like to me I've got 3 pieces. I've got one here, 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 and here. So I've got 3 equations I need to do. I've got 4 numbers in my boundary lines though. So you can pick whatever you want to start your function. So I'll just change it up. Instead of using f of x, I'll do h of x. Okay, big brace symbol. So I'm just going to start with the one on the left. So this equation right here. That looks like it's a horizontal line at -2, so I'm just going to write -2. And then I'm going to put the boundaries over here. And so if you always go smallest to biggest, your symbols will always face the same direction. That way you don't have to worry about greater than, less than, which way they go. If you go smallest to biggest, your symbols always face the same direction. Okay, so, whoops. Keep getting that highlighter. Let's just do that again. Okay, so this one is at -8, and this right here is at -3. So all you have to do is go and look on your boundary points. Looks right here is an open circle, here's a closed circle, so this should be less than or equal to, and the -3 should be open. Okay, now we're going to do the equation of this slanted line right here. Now, unfortunately, this slanted line doesn't work really nice to do y equals mx plus b, because I really don't know if that's crossing at 1, 2, 3, 4, 5, 6.5. Maybe it's 6 1/3. Maybe I don't know what it is. So unless I can really be sure, I can't do y equals mx plus b on this one. So I'm going to do transformations with the point slope formula. So what I'm going to do is figure out its slope, because no matter what formula I'm going to use, if I'm finding the equation of a line, I need its slope. So I'm just going to count it out. So it looks like to me the slope is 1, 2, 3, 4, up 4, 5, over 1, 2, 3, 4. So slope is 5/4. And now I'm just going to do transformation. I'm going to pick a point. It doesn't matter which point you pick. You could actually do, and there's actually 4 equations you could use for this. So I'll pick the point right here. I'll pick this point here on the left, which is -3, +3. So I could go x plus 3 plus 3. That's one equation that works. And for the boundaries, I would just put x is less than 1 and -3. Okay, so here's your boundaries. Okay, another equation you could write is you could write 5/4. So now I'm not going to keep you don't want to put all these in your piecewise. You only put one, but I'm just going to write down the other ones. We could have, our slope doesn't change, it's still 5/4. We could have done the other point right here, this point right here, and we could do that as 1, 8. So x minus 1 plus 8 with the same boundaries. We could have viewed this as maybe half of an absolute value symbol. So we could have done 5/4 absolute value of x plus 3, meaning it was this left-hand or right-hand side of an absolute value. Or you could go the other direction and do it as an absolute value facing down. So you could have done negative 5/4 absolute value and pick this point right here as your vertex and using the left-hand side. So you would just say x minus 1 plus 8. So for that middle piece right there, equation, you could have come up with 4 different scenarios, and they all would have been okay. I'm just going to leave the first one that we had. I'm going to erase all those. Okay, and then we need the last one over here, which is a horizontal line at 9. And the boundaries for that one are between 1 and 6. And it's equal to 1. So I'm going to close circle that. Oh, I erased this one right here is to 1 right there. Okay, so there's our equation of our piecewise. We'll do this one more time. So this one right here, I'm going to put my boundary lines in just so I can see what I'm working with. Got one right here, one right here, one right here. Okay, I'm looking at this V shape right here. I was kind of thinking I want to do an absolute value, but now that I look at it closer, I can see that this distance right there is 4 spaces, and this distance on the left is only 3 spaces. So I can't do that as one absolute value symbol. I'm going to have to break that up into 2. I wanted to do that as one absolute value, but I'm going to have to break that up into 2 pieces since it's 2 lines. So let's get that boundary line in there. Okay, so let's go ahead and do what we did on the other slide for that equation of that line. I don't want to do y equals mx plus b because I don't know what the b is. So I'm going to do the point slope transformation. So let's count out what our slope is. It looks like to me this is a negative slope. We're going down 1, 2, 3, 4, 5, 6, 7, and to the right 1, 2, 3. So we're going down 7, to the right 3. And I will just use this point right here. So that's negative 9 and up 2. And the boundaries for that are between negative 9 and 1, 2, 3, 4, 5, 6, negative 6. And it looks like to me they are both closed. Okay, now I'm going to do the equation of the next one. This one right here. So I'm going to count out, that slope looks positive to me, so that looks like I'm going up 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So 7/4. And I'm going to just choose this point right here. And so that's going to be x plus 2 plus 2. And the boundaries for that one are between 1, 2, 3, 4, 5, negative 6 and negative 2. Both of those are equal to. And then I'm going to do the horizontal line next. So this one right here, I'm going to do this next. And that looks like that is at 1, 2, 3, 4. And my boundaries for that are between negative 2 and 2. No underlining on that one because they're both open circles. And then my last equation, this one right here, is another horizontal line, 1, 2, 3, 4, 5, 6, 7 at y equals 7. And that is between 1, 2, 3, positive 4 and 9. Okay, I'm going to fix my braces there so they're a little longer. Encompass my whole piecewise. So let's see, we'll just fix fix that a little better. Not even, but there we go. There's my whole piecewise function. Okay, so a piecewise function is just domains restricted of a lot of functions, and you put them together to create one new function.